We've been observing the planets with telescopes for hundreds of years and sending probes out into space for over 50, so you might have thought that our cosmic neighbourhood would be pretty well explored. But the truth is, we've only just scratched the surface.
The reality is that most of the solar system still remains a mystery.
Once you head out beyond Neptune, you enter a realm that was, until recently, almost completely unknown. Yet we now know that it's full of extraordinary objects.
So tonight, we're going to explore this unknown area. We're going to venture out into this dark zone.
Since Pluto's relegation to dwarf planet status, the planets of the solar system now end at Neptune. And if you think that all the exciting stuff happens between there and the Sun, you're totally mistaken.
We now know that that dark realm beyond Neptune's orbit is filled with a vast number of strange icy bodies. And as we've discovered them over the last couple of decades, it's become clear that they play a critical role in the evolution of the whole solar system. Tonight, from the observatory at Herstmonceux, we'll explore the incredible objects that we're finding in the outer solar system. Some are on uniquely baffling orbits, while others spin surprisingly rapidly.
And Marcus de Sotoy investigates the surprising mathematical laws that govern these objects, and how they reveal that our solar system is potentially on the brink of catastrophic instability.
This group of strange new worlds needed a name, and we call them the trans-Neptunian objects. But to understand the role they play in the solar system, you really have to see them in context.
Let me paint you a picture of our solar system. At the centre, we have our local star, the Sun. Then the inner planets. Mercury, Venus, Earth, which of course we're on, and then a little beyond, Mars. Then we move on to the outer planets. Jupiter, Saturn. Over here is Uranus, and way over here is Neptune, 4.5 billion kilometres away from the Sun. Now, the images of the planets aren't drawn to scale, but the distances from the Sun are about proportional. Except this isn't the outer edge, not by a long way.
Because beyond is the realm of the trans-Neptunian objects. Most are in a region called the Kuiper Belt. Pluto, for instance, is here. One called Haumea is here. Another called Eris sits here. And some are even further out, or in strange orbits outside the plane of the solar system. The Kuiper Belt alone is huge, some 16 billion kilometres wide. It forms a flat disk, lying in the same plane as the planets. And within it are hundreds of thousands of new objects, maybe millions. Trans-Neptunian object hunter Michelle Bannister has been using some of the most powerful telescopes in the world to search through this dark zone. She tells Chris about some of her most exciting discoveries.
Well, the outer solar system is a fascinating and interesting place, but what's been found recently?
Well, we've just wrapped up one of the largest surveys ever made of the outer solar system, and we've been able to double the number of trans-Neptunian objects orbiting outside Neptune that are known, that have really well understood orbits. We've been able to discover more than 800 icy worlds, little objects about 50 to maybe 300 or so kilometres in size, most of them, that orbit beyond Neptune. These are leftover pieces, planetesimals, from the formation and evolution of the giant planets.
So it's very exciting. I've got a picture of one of your discoveries here.
This goes by the delightful moniker of 2015 RR245. So RR245, it's a lot bigger than some of these others. This is bright. This is really bright. And when we found it, It's moving across the sky over 3 hours in these 3 images you see here, really slowly. And because it's bright and slow, that means it has to be very far away. It turns out it's about 700 kilometres across. It's one of the 20 largest dwarf objects in the outer solar system.
So what's a world like this actually like? What's it made of, and what would it be like to be there?
What you probably would see is a surface of complex ices, definitely water ice. On Pluto, we know that water ice makes mountains. So here, maybe you'd see terraces and small mountains of some water ice. You'd also see reddish layers on the surface, and that's because RR245 is probably large enough that it has some of the complex molecules that form on icy surfaces over time from hydrocarbon molecules being bombarded by the slow rain of cosmic rays.
So I've got a picture of one of my favourites. This is an artist's impression of Haumea, which was one of the first to be discovered.
Yes, it was discovered back in 2003, and we now know a lot more about this wonderful icy world. This is one of the strangest objects in the outer solar system. It's shaped in this elongated way like a rugby ball, because its spin axis is actually here. So it's spinning like this, and it spins every 3.9 hours or so.
That's really fast. These are big
It's one of the fastest
things.
things in the solar system, spinning. Yeah, this is spinning so fast that the solid rock itself that makes up most of this object is actually flowing out, and that gives it this elongated shape.
How are they arranged?
Some of them are in a flat disk, so they have round orbits that are flat. These are probably the ones that have changed the least since the formation of the solar system in the Kuiper Belt. Then you have ones where their orbits have been dynamically changed, so they're actually excited. They have tilted orbits out of the plane of the system. Not a whole lot, but about a few tens of degrees.
What are the big new discoveries still lurking out there?
There's some fun indications that we could have another dwarf planet out beyond Neptune that we haven't yet found. This could be as big as a Mars-sized object. And this ties into an object that was found about 1.5 years ago now by a different survey in Hawaii. And this object, it actually orbits perpendicular to the plane of the solar system.
Is it called Niku?
It's called Niku.
Okay, well, I was going to talk to you. There's Niku in all its glory. I have to say, it doesn't look like much.
It's
Fine.
got charisma,
All right,
I tell you.
We'll go to the theory. There you go. There's the theory.
We watched this object move across the sky over several years, and therefore able to do the computation of its orbit and show this orbit is strange.
So this is Jupiter, Saturn, Uranus, Neptune, all
Yep.
in a plane, and the
All in a
Earth would
plane.
be in this plane as
Right.
well.
But this object orbits perpendicular to the plane of the solar system. And this is a mechanism that we don't have a clear idea yet of how to form orbits like this. You can make a comet that goes way out and then comes back in on such a perpendicular orbit. But making something that's relatively small and close, this dips in amongst the giant planets and then zips out as far as the Kuiper Belt. Except the Kuiper Belt's over here. It's, in a nice, relatively even disk. Nothing does this in the Kuiper Belt.
Every time I talk to anyone who studies the outer solar system, I end up with more questions. So I hope you find more things. I hope you come back and tell us about them. Thank you very much.
Thank you.
The more we peer into this dark zone beyond Neptune, the more mysteries we discover.
For most of astronomical history, these trans-Neptunian objects have been hidden from even the most powerful telescopes. And that's why they've never got the attention they really deserve. But these days, are they so impossible to spot? To find out, we set Pete Lawrence a challenge to try and see a trans-Neptunian object using amateur equipment.
Well, I've been given some tough challenges on the sky at night before, but this one has to be up with some of the hardest I've ever had. These objects are, after all, tiny, dark, and a long, long way away. But I've decided to try and observe Haumea. The reason I've chosen that particular one is that it's really well placed at present. It's actually located just between the midpoint, or just south of the midpoint, between the stars Arcturus and Muffred. And both of those stars are in the constellation of Boötes. Now, I know the exact position of Haumea because I've looked it up on the JPL Horizons Ephemeris Generator. That's a free online resource. And I can tell you it's pretty faint. It's about magnitude 17.6, which is about 36,000 times fainter than the faintest star you can see with the naked eye. To attempt this observation, I'm using my 130mm telescope with a DSLR camera and my laptop to process the images. We are trying to capture this very close to the June solstice, so the sky is still really bright. In fact, the threshold of brightness is too high really to pick out anything really faint. It's a little bit frustrating because I'm confident that under darker skies, for instance later in the year, I'd be able to make this work. I did have an inkling this was going to happen, so a month ago I did dial into a remote telescope setup in New Mexico. This is a commercially available telescope that anyone can book time with on the internet. The one I'm using is actually smaller than mine, but the skies in New Mexico are fantastically dark. And these are the results. Well, looking at the New Mexico results, they're much clearer, that those dark, transparent skies have really worked for us. But how am I going to find Haumea amongst all those stars? Well, I'm going to use a classic technique which is known as the blink method. So the blink method works like this. The object I'm looking for will move over a period of days. So if I take a picture on one day and then wait a few days, take another picture, and then I align the stars between those two pictures and then blink between them, anything that moves should stand out like a sore thumb. This is the same technique that was used in the 1930s by Clyde Tombaugh to spot Pluto. And these are the images he took over a week that eventually revealed Pluto's existence. Hopefully, that same technique should work for me. And there it is. I can see it. I can see the dot moving backwards and forwards. Now that represents the movement of Haumea over 6 days. So the blink method has worked. That's incredible, isn't it? I mean, that's an object which is just a few hundred kilometers across and about 7.5 billion kilometers away. That's amazing. If you'd like to try and spot a trans-Neptunian object, we've put some information about the positions of Haumea, Makemake, and Niku on our website. And please do drop us a line to let us know how you do.
It's not just our instruments that have improved. We now get much more information about objects in deep space from missions like New Horizons.
3, 2, 1. We have ignition and liftoff of NASA's New Horizons spacecraft.
NASA's space explorer New Horizons reached Pluto in 2015, and it's still exploring, venturing deeper into the Kuiper Belt. It revealed new information about both Pluto and its moon, Charon. It found unexpected warmth on Pluto and a mysterious dark red area on Charon's North Pole. Maggie spoke to New Horizons team member Carly Howitt from her base in Colorado for the latest updates on these mysteries and to see where they're going next in this dark zone.
Hi, Carly. Good to see you again.
Yeah, you too. It's good to be here.
Now, last time we spoke, it was incredibly exciting because New Horizons had just flown past Pluto. So what have been the most exciting findings so far?
So I think there's two that really jumped out for me. One is actually to do with Charon. So Charon, of course, is Pluto's biggest moon. It's most of the same size as Pluto. It's very large indeed compared to its orbital parent body. And so we didn't know it had a red pole. And so there was a lot of work that's gone into trying to understand what's going on.
And now, after 2 years of analysis, Carly's team think they finally have an answer. Charon is stealing Pluto's atmosphere, which is freezing at its poles, then turning slowly red.
So we think that Charon's poles are red because they're sort of nabbing some of Pluto's atmosphere as it's being lost, which I think is phenomenal. But this process happens incredibly slowly. So Pluto has a very thin atmosphere, and so you end up with about 1.5 millimeters per million Earth years. So this process is not something that's happening overnight. This is a very, very slow process, and it tells you really that Charon's surface must be incredibly stable. There's not sort of an overturning, there's not a change in the surface, because otherwise that reddening couldn't have happened.
But there's also talk that Pluto has a heat source. Has that been confirmed?
The origins of that is that there's these shapes that have very discrete boundaries, and what we think is they're like lava lamps. So they're getting heated from the bottom and slowly the material's rising up and then falling back down again. Now, there's two ideas. One is that the energy source from that is from the interior and it's leftover radioactive decay.
If it's radioactivity, wouldn't it have decayed long ago?
So we think that actually there's enough remnant radiation, because you just don't need enough, you just need a little bit. And we're still trying to figure that out, whether it's just purely sunlight, whether sunlight's enough to drive it, or whether we do need to sort of invoke extra radiation, sort of a superpower for Pluto from radiation to allow this convection to happen. But we certainly don't need a lot of heat for it to happen. A few degrees is all that's needed.
And we've got all these fantastic results, but what's next for New Horizons?
New Horizons is still busy. We found another target for it to visit. It's got a very catchy name of 2014 MU69. And this is a very small object that's located in the Kuiper Belt. We think it's never been heated up. So again, it's this sort of remnant of the early solar system, which is, again, important in order to understand our own solar system formation theory. It hasn't been modified since basically the dawn of our solar system, so it's very exciting. So we're observing things en route, but our next target we reach on the 1st of January in 2019. So there's going to be quite a lot of scientists that are going to be very sober on New Year's Eve 2018.
So, Carly, what have we learned from its journey?
Oh, we've learned so many things. I think we've learned that this region of space is not boring. It's not dead. Activity is happening. There's variation across different targets. This is a region of space that really wasn't known very much at all, and it's completely revolutionized our understanding of these targets.
Well, Carly, thank you for talking to us again, and we look forward to getting the latest results as they come through.
Thanks for your time.
Most of the trans-Neptunian objects are leftovers from the origins of the solar system. This means they contain important clues as to how it evolved. Scientists believe they've played a significant part in the solar system's most turbulent period, a time when the orbits of the planets changed dramatically. And they suggest there's a chance that this might happen again. To understand how such relatively small objects play such an important role, you need a very particular tool: mathematics. Marcus de Sotoy explains.
For a mathematician like me, what's so fascinating is that the planets, the moon, the stars all move through the night sky following very strict mathematical rules. And this idea is perfectly captured by this thing here. It's called an orrery.
An orrery is a model of the planets revolving around the sun that runs on one of the most beautiful mathematical systems, clockwork.
Mathematics describes the clockwork nature of the way the planets move around the sun with such remarkable detail that we're able to make predictions about where the planets will be into the future with pinpoint accuracy.
This is because of Newton's theory of gravity, a mathematical equation that shows how objects attract each other through gravitational force.
Crucially, this means that as the planets and other objects move, they can influence each other in ways that can be very profound. Let's suppose this metal ball is a planet orbiting the sun. So set it off on its orbit. And I'm going to use this magnet to represent the influence of a second planet. So I should be able to give a kick to the stable orbit of this first planet. Yes, you were starting to influence the orbit of the first planet in quite a dramatic way. When one object or planet affects another via gravity, we call it perturbation, and it's an influence which has had a major effect on the solar system. And over the years, we've used the mathematics of perturbation to solve some of the great mysteries of the solar system.
For instance, in the 19th century, the predictions of the position of Uranus were discovered to be wrong. And mathematicians guessed this could actually be due to another planet perturbing the orbit of Uranus. And within 20 years, they found it. It was named after the Roman god of the sea, Neptune.
Mathematics doesn't just help us to predict where objects will be in the future. It also helps us to understand the very structure of the solar system, how it evolved and how it might eventually end.
And many believe that the trans-Neptunian objects are evidence of this mathematics at work, because of my second mathematical principle, resonance.
This is a Barton pendulum, and it shows how under certain circumstances a regular pattern can powerfully influence another through something called resonance. I've got a series of pendulums hanging from a string here, and I've got a driver pendulum. And when I set this off, the energy is going to get transferred to the other pendulums, but they're not all going to react in the same way. What we see is that these two pendulums are swinging much more than the others, and this is because they're in resonance.
Resonance occurs when a pendulum absorbs the momentum easily from the driver and relates to its length. And some lengths work better than others. So here, the length of the string is the same as the driver. And this one is in a 2:3 ratio.
Amazingly, the same thing can happen with the planets and the moons. The gravitational attraction as they orbit means that under certain circumstances, they can begin to resonate. So they kind of get locked in, creating a regular pattern.
For instance, Pluto resonates with Neptune, orbiting twice for Neptune's 3 times. And the trans-Neptunian objects resonate too. Although this resonance seems to create order and balance, it's not guaranteed, because, as with any finely balanced object,
it's easy for it to become destabilized. Which brings us on to another mathematical subject called chaos theory. Roughly speaking, the idea reveals how a small change in the present can have dramatic implications for the future. Consider this pendulum here. If I set it off, then it does exactly what you'd expect it to do. If I now add a magnet to the base, then it perturbs the orbit. It's still pretty predictable, but it's beginning to wobble. But now, if I add 2 more magnets to the base, the orbit becomes wildly unpredictable. More accurately, what mathematicians mean by chaos is that a small change in the starting position can cause a completely different outcome for the trajectory of the pendulum. What we've come to realize in the last few years is that our solar system has much more in common with this chaotic pendulum than we ever imagined.
far from being stable and predictable, it's actually unstable and chaotic. And a small wobble of a tiny object could, theoretically, change the whole structure of the solar system completely.
But how about this for a thought? Scientists now believe that chaotic disturbances have already played a critical role in the history of our solar system.
In particular, they suggest there may have been a chaotic resonance catastrophe around 4.5 billion years ago. As well as messing with the planets, this might also finally explain the weird orbits, spins and positions of the trans-Neptunian objects. To find out more, Chris met up with Marek Kukula of Greenwich Observatory.
So what's the story? What did happen 4.5 billion years ago?
Well, the most popular model for what might have happened is called the Nice model. It's named after the Observatoire de la Côte d'Azur down in Nice in France, where the model was first come up with in 2005, I think. And the idea here is that the giant planets Jupiter, Saturn, Uranus and Neptune were all in very neat orbits but closer to the Sun than they are now. And beyond them was this very thick, dense Kuiper belt, very different to the one that we have today. So although it looked, perhaps from the outside, very neat and stable, actually the seeds of its own destruction were already there. And what happens is that the giant planets are able to pull in the smaller objects from the Kuiper belt and they flick them inwards. But when the small objects start to get into the realm of Jupiter, then something a little bit different happens. Jupiter, obviously the most massive planet, its gravity is very powerful. It's able actually to flick these objects not further in, but further out. It's flicking them perhaps even out of the solar system entirely. And of course, if it's flicking them out, it has to move further in. So Saturn, the other giant planets, are moving out, Jupiter is moving in, and then you get to the situation where we have a resonance, where Jupiter is going around the Sun twice for every one orbit that Saturn makes. That resonance is a very powerful situation. And that means that as they do that, they're giving very regular gravitational tugs to Uranus, to Neptune, and to the Kuiper Belt objects. So what you get is, as Jupiter and Saturn are doing this resonance thing, they are pushing Uranus and Neptune further out, and they push them out into this dense Kuiper Belt. That's very chaotic. These smaller objects are being thrown in all directions. Many of them are being flung into the solar system, and this is where all hell breaks loose.
This computer simulation shows this moment of resonance followed by chaos. The Kuiper Belt is in green, and the outer planets are in the centre. Suddenly, Jupiter and Saturn wreak havoc, and the Kuiper Belt is scattered.
When that process has finished, Uranus and Neptune perhaps swap places. They and Saturn have moved further out from the Sun. The Kuiper Belt has been scattered in all directions. It's now much less dense and much more extensive. And this is why we have the solar system that we have today.
So when we think about the chaos that still exists in the solar system today, or the potential for chaos, the fact that things could change, what's the worst that could happen? Should we be worried?
Well, perhaps a little bit worried. If you look at the solar system as it is today, it does look fairly stable, but in fact that's an illusion. And if you look at all of the orbits of the planets, the other objects, the Kuiper Belt, the asteroids, it is still rather a chaotic system. It turns out that Mercury's orbit is not particularly stable, and there is a small, perhaps 1% chance that over the next few tens or hundreds of millions of years, Jupiter's influence on Mercury could cause it either to crash into the Sun, to fly out of the solar system entirely, or perhaps even to crash into either Venus or the Earth.
So no sign that that's happening, but we can't be certain.
We can't rule it out. It's a small possibility, but it is a real finite possibility. So we're still living in chaotic times. The chaos isn't over yet.
It seems now that the exploration of the weird world of trans-Neptunian objects is presenting us with a new chaotic picture of our solar system. This is light years away from the stable, predictable one we thought we knew before. And there's still so much more to explore.
I'm so impressed by what's being found in the outer solar system, the diversity of worlds, but also their sheer number. 800 new places in that one survey alone. And who knows what else is out there.
But that's the exciting thing, I think. We're discovering new things all the time. And by looking at these objects so far away from the Sun, we're discovering about the evolution of the whole of the solar system. That's all we have time for in this programme. But do join us next month, when we'll be looking at the profound effect that space has here on Earth. From a deluge of space dust, to the beauty of a meteor storm, to the potential for life itself.
And in the meantime, do check out our website at bbc.co.uk/Sky at Night, where you'll find exclusive content, including a star guide.
In the meantime, of course, get outside and get looking up.
Good night.
The Sky at Night was granted unprecedented access inside the Vatican for a special programme, God's Own Observatory, available now on BBC iPlayer. Coming up, preparing for a 2 billion mile journey into space to answer a question that never really goes away. Is there life on Mars? BBC4 investigates with Destination Titan next.